All right, this is the last example of chapter 5. It is question 95. Let's read the question first. Question 95. A current of 20 ampere is flowing through a 71-meter long hollow cylinder. The inner radius of the cylinder is 0.8 centimeter and the outer radius is 1 centimeter. Due to the resistance of this conductor, 0.096 kilowatt of energy is lost every single day. What material is this conductor made of? Now note in the diagram of this question we're given a list of the resistivity of all the material. So this question really is asking us to find the resistivity of this material so that we can deduce what it is made of. So we have a diagram here with a wire that has a length of 71 meter. It has a current flowing through it of 20 amp. Now it is a hollow cylinder, which means this part here is empty, and at some point we will need to calculate the area, the cross-sectional area, and since the inner section is empty, we will need to extract the area from that section to get the total area. All right, so before we do this, let's just highlight all the different value. So we're given 0.8 centimeter for the first radius. Again, we switch it into meter. The second radius is 1 centimeter or 0.01 meter. Energy loss every single day is 0.096 kilowatt hour. That's for every single day. Okay, so there's a couple of pieces we need to solve and then we are going to put everything together. The first one being we need to find the area, the cross-sectional area. Now, if the cylinder was full, we will simply use pi r square. Now we cannot do this here because it is empty in the middle. So what we do is we calculate the area of the bigger circle and we remove the area of the smaller circle. So pi r2 square minus pi r1 square. All right? It is equal to 1.13 multiplied by 10 to the power minus 4 meter square. All right? We got the area. Now we want to know what is the power that is, or the amount of energy that is being consumed every second. We are given the energy in a day. So if you want to find the power, we need to take the energy in a day and divide it by the time in a day, the time in second. So the energy, and there's a catch here, we need the energy in joule to use that formula. So we need to convert from kilowatt hour to joule, so simply multiply by 3.6 multiplied by 10 to the power 6, or if you want, you multiply by kilowatt, so it's 1,000 multiplied by the number of seconds in an hour, 3,600, and we get back to that value anyway. We divide by the number of seconds in a day, so 24 hours, 60 minutes every hour, 60 seconds every minute, and we get a power of 4 watt. Okay, we got our watt. Now we are in a position to find the total resistance of this wire over here. So the power is equal to V multiplied by the current. We don't have the voltage drop here, but we do have the current. So we replace voltage by using Ohm's law, and we get a voltage equal to IR. So we got the power is equal to I square multiplied by R. We isolate the R, we get 0.01 ohm. So this conductor has 0.01 ohm. All right. Now at this point, I will need to erase that part at least to continue. So if you need to write down anything, pause the video, do it now. All right, so at this point, we want to use the relationship between the resistance and the resistivity. We got everything at this point. We got the resistance, we got the length, we got the area. So we just need to isolate the resistivity. It is equal to the length multiplied by R multiplied by the area. So resistivity become equal to, let's just complete this computation. Oh, there's a mistake here. resistivity, we flip the A, divide the L. Okay, so it's R multiplied by A multiplied by L. All right, that makes way more sense now. So let's have a look at this. So area 1.3 multiplied by 10 to the power minus 4 multiplied by 0.01 and divided by 6. And we get 1.6 multiplied by 10 power minus 8 ohm meter. Let's have a look at our table. So basically the closest one will be silver. It's 1.59 multiplied by 10 power minus 8. So according to this, hollow cylinder is made up of silver. All right. So by the way, that's an interesting question, and you can expect that you will have some questions similar to that one in the test. All right. It combined a bit of everything. We got Ohm's law, we got the resistivity, we got the power in kilowatt hours. So it's a really creative question. Okay. Make sure you practice that one. All right. So we are done with chapter 5. Next chapter, we are going to dive into the world of electrical circuit. All right. So see you in the next video.